All right, for number 7, we have the rate law for this. When you are presented a table, this is kind of like a standard way to ask you this question, so you know what to look for. You would look at experiments and experiment 2 because the concentration of A is doubled, and then you look at the rate of formation of C, it's also doubled. Okay, um, so. So that's how we know the concentration of A, it's raised to the first power, it's first order. And then the second question is, what about B? What is the order of B? So we look at experiment 2 and 3 and we say, hey, that is an increase of 5 times. What about this? Is it an increase of 5 times? Doesn't look like it. Okay, so in order to compute this, I'm putting into my calculator 1.25 times 10 to the negative 2 divided by 5 raised 5 times 10 to the negative 4. This is a 25 times increase. Okay, so use your calculator. So that means, what's the order for B? Second order. So our rate law, it's going to be this. And again, you write the word rate and you keep the K right there. You don't have to find out the K value until they instruct you to do it in part B. Okay? Part B. Part B. Part B. Part B is what? Part B is to find out the value of K. All right, now, now finding the K is easy. I'm more interested about the units. Can you tell the units of K? What's the unit for K? 1 over molarity square, and then seconds. Yeah, you have seconds right here. Okay. Why is it molarity square? Because there's a molarity cube from those two concentrations. And our rate, as you can see right here, it is molarity per second. As we said last week, you have total freedom and authority to create K, to create the unit of K, as long as the unit on the left, which is molar per second, is exactly equal to the unit on the right. Okay? And you can pick any experiments to calculate this K value because it's supposed to be the same. So I'm just going to keep it simple using the first experiment. All right. And then 0.1 times 0.1 square. So 2.5 times 10 to the negative 4 power divided by 0.01 cube. And that would be a number of 250. Okay, so 250 is the value of K, and make sure that you write down the proper unit of K as well. Okay, so far so good? 250? Yes, 250. 0.0. Oh, sorry, no, my bad. I typed in the wrong number. Sorry, something did not click. It's not 250. I was like, wait, hold on, that's a little bit too big. Is it 2.5 or 0.25? Yes. I was like, wait, hold on, that is just 0.1. I typed in 0.01 for no good reason. My radar started buzzing because I was like, wait, hold on. 0.1 to the third power is just 10 to the negative 3. How am I getting 250? What's that? The 25? You just do division. Uh-huh. Oh, big number minus small number, right? So 1.25 times 10 to the negative 2 divided by 5.0 times 10 to the negative 4. And you did not put parentheses around the scientific notation. And I never suggest this. Use the EE notation. So if you do 1.25 and then second, yep, second EE, and then you just type the exponent, -2. Okay? That if you use this notation, you do not have to type in parentheses. But if you say, oh, I type in this exact scientific notation, then make sure, especially when you're dividing, put a pair of parentheses around that number. If not, second.
You don't have to put the 10 to the.
No, that E thing is times 10. So you just put in -4. Okay. Yeah. That's it. So it's 25. Yeah. 2.5 times 10. All right. So make sure that you know this.